Hello, am I audible? Daksh, am I
Yes, sir.
audible?
Yes, sir.
Okay, okay. All right. Yes. So, Charan and Nikhil, please tell me, were you able to solve this question? Anyone, any ideas?
No, sir. Can you explain it?
Okay. We'll do it. Let's ask from Nikhil as well. Nikhil?
No, sir.
Okay, right. Please see. This question, let's read it again. Charan, can you read this question again? Then I'll start with the explanation. Charan, can you read the question again? If you can hear me. It seems Charan cannot hear me. Nikhil, can you hear me?
Yes, sir.
Nikhil, please read the question, then I'll explain.
Calculate average molecular mass at equilibrium. Also find.
No,
So should I
it's
read that?
no. Yes. Data is given. Alpha is equal to 0.4.
Yes. Alpha is equal to 0.4 for gaseous reaction. PCl5 gives PCl3 plus Cl2. Calculate average molecular mass at equilibrium. Also find density of equilibrium mixture at 1 atm and 400 Kelvin. Molar mass of reactant is given to be 208.5 grams.
Okay. So there were two things which were to be found out in this question, and the two things are average molecular mass at equilibrium, first thing, and the second thing is the density of the equilibrium mixture. So average molecular mass at equilibrium, this can be found out by the term d, small d. Average molecular mass at equilibrium is similar to small d. How? Small d is supposed to be vapor density, and vapor density is equal to average molecular mass at equilibrium divided by 2. Okay, so we can replace these capital D's and small d's with the uh, molar masses or molecular masses. We can do that. Let me, yeah, I have written the formula in the previous class as well. This is the, let me highlight it for you. This is the formula which we can use. Instead of capital D, I am writing capital M, which is mass of reactant. Basically, this is the molar mass of the reactant. In short words, you can say this is the molar mass of the reactant. Molar mass of reactant, and small m is the average molecular mass at equilibrium, or average molar mass, of mixture at equilibrium, obviously, because at equilibrium the mixture is there, but initially no mixture is there, only the reactant part is there. Okay, so in the previous class we have done alpha is equal to capital M minus small m divided by small m into n minus 1. By this we have calculated the small m part, which came out to be 148.9. So one part of the question we already did in the previous class, that was average molecular mass. Now coming to the second part. I hope the first part is clear to everyone. Please tell me if it is not clear to anyone. If you are having any problem in this first part, I'll move on to the second part then. Charan and Nikhil, is it clear to you? Please tell me, please confirm.
Yes, sir.
Yes, sir.
Okay. Daksh and Niranjan, is it clear to you?
Yes,
First part?
sir.
Okay. Niranjan?
Yes, sir.
Okay, great. Now let's move to the second part. The second part says density of the equilibrium mixture. Now, please observe, we have talked about two different densities. One is the vapor density and the second one is the actual density. Vapor density is molar mass divided by 2. Okay. So this vapor density is very, very different from density, which we know. Density, which we know, is mass by volume. Okay. But vapor density is not mass by volume. Vapor density is something else. Okay. Now we are dealing with the actual density. We need density of equilibrium mixture. Obviously, to calculate density of equilibrium mixture, we would need a equation, and that equation is Pm is equal to dRT. This equation comes from the chapter of gaseous state. Pm is equal to dRT. It is derived from PV is equal to nRT. I hope you recall PV is equal to nRT. How do we derive it? We substitute N by N is moles. Moles is given mass divided by molar mass M. Then what can I do? I will shift this M here and bring this V down here. So what can I get? I can get Pm is equal to given mass divided by volume, and this thing is density. This thing gives us density given mass by volume. Okay. So P into M. M is molar mass, not any mass, but molar mass, is equal to dRT. Please tell me, do you know Pm is equal to dRT? Is it fine?
Yes, sir.
Yes.
Great. Now the question becomes very, very simple. You know T is given to be 400 kelvins in this question. R you already know it is a constant. Pressure is given to you 1 atm. And now you need the molar mass of the equilibrium mixture. And the molar mass of the equilibrium mixture, you have calculated it here. This is the molar mass of the equilibrium mixture, 148.9. And hence, now it's easy, I suppose. Yes, is it all right?
Yes, sir.
Okay, please copy this.
Sir, we got it till here in the last class.
Till where? Pm is equal to
Till
dRT.
148.9.
Yes, till 148.9 we got in the previous class. That's true.
Yes.
That is true. Yes, yes.
But from that 2.69, what do we do?
I just explained Pm is equal to dRT. You have to calculate
Yes,
D by taking P, M, R, and T. Just check it out.
No, I had a doubt.
Yes, please.
So in the question, you have given 400 degrees Celsius.
Yeah, it was a mistake. I corrected it. It was not degree Celsius, but Kelvin.
Kelvin.
Yeah. Please check it if density is coming out to be 2.69. Niranjan, have you done all these things and only there was a problem of 400 degrees Celsius in your answer? Otherwise, it's correct.
Yes, sir, I think so.
Very good. Very good. That's very good. Please confirm if the answer is coming 2.69 around. What is the value of R you are going to take? Yes. 0.0821.
So 0.082.
Yeah, it will do. Not an issue. You can use the calculator because we'll be doing, I hope that you know how to add, multiply, subtract, and you won't do mistakes there. So in order to learn concepts, you can take the help of calculator. Come on, has anyone got the answer? D. Come on. Should I calculate it for you? Are you getting 2.69? Has anybody not got till now the answer? I am getting 4.53. Yeah? Is it?
Sir, but 4.54.
4.54, yes.
Yes, sir.
4.54.
Yes, sir.
4.54. Let me just check again. I'm sorry, the answer is 4.54, not 2.69. I have calculated the answer wrongly. It is coming to be 4.54. D is 4.54. That's it. Let's move to a different concept now. We have covered till now degree of dissociation, vapor density in relation to the degree of dissociation, and now we are going to see a different concept, and this concept is known as Arrhenius equation. Just a moment. I hope previous question is clear. There is no doubt left. If there is any, please let me know. Okay. Okay, great. Yes. Now, in this next section, we are going to study some things about activation energy, how the reaction goes, what path it takes, what are the energies involved, and we are also going to relate the equilibrium constant with the temperature variance or dependence upon the temperature of the equilibrium constant. Now, you all know, can anybody tell me what are the factors on which the equilibrium constants depend? What are the factors by which you can change the value of equilibrium constants? Can you name them? Is concentration one of them? If I vary the concentration of a reactant, will the equilibrium constant change?
The rate of reaction.
Rate of reaction, what rate of reaction? Please complete your statement.
So the value of equilibrium constant depends on the temperature.
Only on temperature.
Yes, that is correct. Only on temperature and nothing else.
Sir,
You keep on
gave that a
changing.
lot. Yeah.
Pardon?
Sir, you gave that point. You told that the value of equilibrium constant depends only on temperature.
Yes. I told you that equilibrium constant value depends only and only upon the temperature. You keep on changing the concentration of reactants, products. No change in the equilibrium constant. Change the pressure, no change. Change the volume, no change. Change any other thing, no change. Okay. Temperature is one very important factor which governs the equilibrium constant of a particular reaction. Now we are seeing dependence of K on the temperature or temperature dependence of K. Please write the heading, then we'll proceed. Temperature dependence of K. Now it is given temperature dependence of equilibrium constant is given by the Arrhenius equation. So we knew up till now that K depends upon temperature, but we never knew what is the actual relation. Now here in front of you is given the actual relation, which is showing the dependence of temperature on K. And this relation is known as Arrhenius equation. The relation goes by this: K is equal to A into E to the power minus EA by RT. Now what are the different variables involved? I have mentioned them as well. K is rate constant, A is pre-exponential factor, which tells you total number of molecules colliding in a particular reaction. So A gives a very fair idea of total number of molecules colliding in a particular reaction. What is EA? EA is activation energy. You all have some idea of activation energy. R is gas constant and T is the temperature. We are going to do some more calculations upon this equation. Please write it down neatly. Let me know when you have written.
Done.
Okay. Yes, Charan.
Yes, sir.
Daksh, done.
Yes, sir.
Okay, let's go ahead. Now let's see something concerned with the activation energy and the how the reaction goes. Let's see. So activation energy, you know what is activation energy? It is represented by the symbol capital E and subscript A, small a. It is the minimum amount of energy required by a reactant to convert to a product. Okay. And in front of you, this whole graph is the energy graph. On y-axis is the energy, and on the x-axis is the reaction time, you can say, or reaction coordinates. As the reaction proceeds, it is showing the energy curve. Let's say the reactant was having this energy. The reactant was at this level, indicated by this point, this particular point. And then from here, as the reaction proceeds, the energy keeps on increasing like a mountain. There is a peak, and from that peak, the energy again falls down and becomes stable to a particular point, which is known as product. Okay. Now, in this whole curve, the energy is indicated and the difference of energy is indicated. We are going to observe. Please see this difference from the reactant to the peak of the mountain is known as EAF. EAF is activation energy of the forward reaction. F means forward reaction. Similarly, on the similar lines, the difference between the product and the mountain peak of the mountain curve here is known as EAB. B denotes backward reaction. Now, there is a difference in energy between the position of the reactants, the energy of the reactant, and the energy of the product. This is given by delta H. Delta H we have already studied in thermodynamics. Delta H is enthalpy change. Okay, delta H is enthalpy change. Now, this particular curve is a endothermic reaction. How is this an endothermic reaction, and what are supposed to be the endothermic reactions? The reactions which absorb net heat are known as endothermic. So here as well, the product has a higher energy as compared to reactant. Then it is for sure that this reaction has absorbed net heat and not at all given out anything. Hence, this is a endothermic reaction. Now, let's write this all. Then we'll move forward. Please write activation energy. Draw a neat curve. Nikhil, has this portion been covered in your syllabus there? Yes, Nikhil? Am I audible? Nikhil, I am not able to hear you. Are you trying to say something? Was there a problem in the network, Nikhil and Charan? Yes, I can. Okay, I didn't disconnect. Might be disconnected due to the network problem.
Sir, even
Yes,
I got
I.
disconnected.
Acha. Maybe due to the network problem on your end. So I was asking to you people that have you covered this topic in your FITG course till now? Yes. Am I audible? Or is there a problem in the audio? Nikhil and Charan, can you hear me? Nikhil, can you hear me?
Sir, no.
Child, can you hear me? Is my am I audible? Is my voice coming to you properly? There seems to be some problem in the network today. Charan, is my voice coming properly to you? No, Nikhil, I cannot hear you. Some problem in the network.
Sir, can you hear me now?
Yes. I can hear you now, child.
Sir, I couldn't hear you.
Acha. Ha. So now I wanted to ask Nikhil, Charan, you can tell me as well. Is this topic covered there in your syllabus in FITG? The one I'm teaching you right now?
No.
No. Okay. All right. Acha, Charan, can you also tell me the topic which I taught you before, the relation between alpha and the vapor density, was that taught?
Which one, sir?
Just before that, alpha and the vapor density. Alpha is equal to D minus D divided by Dn minus 1. Can you hear me?
Sir, this is breaking.
Yeah, there is not a lot of network issue, I suppose. But is it coming correctly, Nikhil, now? Is the voice proper?
It is breaking little for me.
Is it okay? It is breaking.
Hello, sir.
Okay. Daksh, is the voice coming proper to you? And what about Niranjan? Voice is
So
coming
for
proper to
me, I
you?
can hear you. So I can hear you perfectly.
Okay. So Nikhil, there is, I think there is some connection issue at your end. If you have a one more option of a network of Wi-Fi, or maybe you can connect to a mobile hotspot. Make a mobile hotspot and then connect if Wi-Fi is not working properly. Let me know when you have done.
Sure done.
Okay. Nikhil, is the voice coming properly now?
Yes, sir. It's clear.
Okay. Nikhil, can you please tell me one thing, that the previous topic which we have just completed, the relation between the alpha and the vapor density, was that also not done there with you?
Sir, I don't think it was done, sir.
Okay. So,
Because they finished the
are,
chapter in 5 days for us. And they put
Acha,
test
so,
and now we started organic chemistry.
okay. So, do they have a plan? When will they complete rest of the portion of chemical equilibrium? Is it
So I
Is it
think
something
they
like
will, sir, I don't like they're focusing on JE scoring points. So I think before the 11th board exam, they might.
but that topic which we have done comes only in JE, not school or any other exams. That's a tough topic, that particular topic. Okay,
So they didn't
in
do it for us. Yes.
in organic, where have they gone to till now?
Sir, we are like in ketones, aldehydes, and all that. We finished nomenclature.
Yeah, isomerism.
So what are you doing in ketones and aldehydes? IUPAC.
No, we finished UPSC.
We
So
are doing
what are you?
isomerism now.
No, but what are you doing in ketones and aldehydes right now? Isomerism. What?
Sir, we finished ring
Okay.
chain isomerism.
We did
Okay, that
metamerism
is
today.
okay. So you are doing currently GOC. That section is known as GOC, General Organic Chemistry. First, you have done IUPAC, then you are doing all the types of isomerisms. Then you will be doing the electronic effects, and then you will be proceeding to the hydrocarbons. That will be the pace of the lectures. All right. Okay. Have you completed this, writing this? I hope you have.
Yes,
Yes,
sir.
sir.
Okay. Let's move forward then. Now, on the similar patterns, we observed the graph just now. There is one more graph. And this graph is for the exothermic reaction. So what is the difference between a exothermic and an endothermic reaction? The difference is the position of the curves or the energy of the reactant and the products. Now please notice that the energy of reactant in a exothermic reaction is more. This is the reactant, and by red dot I will indicate the product. This is the product. Product is having much lesser energy as compared to the reactant. And that is why this reaction is called exothermic, which means the net heat is liberated out of the reaction. Okay. And on the similar patterns, delta H here as well is EAF minus EAB. Obviously, EAB is larger and EAF, which is the activation energy of forward reaction, is smaller. Therefore, this will come out to be negative. Please check. This will come out to be negative. Am I correct? Please see. Delta H is negative in a exothermic reaction. Why? Because the EAB is large, or larger than the EAF. Okay. Probably this you would be knowing. Now what we are doing is, after seeing this, we are applying Arrhenius equation to forward reaction. Then I will apply Arrhenius equation to backward reaction. Then we are going to do some derivation. Before proceeding to the derivation, I would like to you to copy this curve as well of exothermic reaction. Please copy this curve. These two curves are very, very famous curves in chemistry.
So should we copy under the graph also?
Under the graph, you have to actually.
The meeting is about to end.
Yeah, meeting is about to end. Okay, then copy just the graph and please tell me when you have completed the graph. Then I'll end the meeting. Then we'll rejoin. Just copy the graph and delta H is equal to EAF minus EAB. I hope you all have copied. Yes, Daksh, Niranjan, have you? Sharon? It was just the graph.
Yes, sir.
Okay. Then let's end this meeting and we'll rejoin.